All right, we are going to begin section 3.2. In the previous section, we had learned about 3 different ways for solving systems of equations. One of those 3 ways was the graphing method. And today we're going to use that same graphing method, but what we're going to be talking about is we're going to be talking about how to solve systems of inequalities. So you'll notice a distinct difference between our problems that we did in the previous section and these ones is instead of having an equal sign, you can see that you're seeing less than, greater than, or equal to symbols instead. Okay, and we're going to talk about how that's going to change what our solution is here today. Okay, so what a system of inequalities is it's 2 or more, instead of equations, inequalities that all have the same variables in them. And again, when you're solving these systems of inequalities, what you're trying to find is you're trying to find all the ordered pairs that satisfy all the given inequalities. Now, a couple things that I just want to kind of review with you before we get into the steps of how to do this. And one of those is when you're working with inequalities, one thing that you want to keep in mind is a special scenario that can tend to happen, and that is anytime that you either multiply both sides of your inequality by a number that's negative, or anytime that you divide both sides of an inequality by a negative number, you have to take your inequality symbol and you have to flip it the other direction. Okay, now let me just show you why that's the case. Let's just remove the variables from an inequality, and let's just start with something simple that we know is true. 3 is definitely a number that is less than 5. If I were to take both sides of this inequality and say divide both sides by a negative number like -1, and I did not flip the symbol the other direction, this inequality is no longer true. -3 is not a smaller number than -5. So this is kind of showing an example of why when you divide both sides of an inequality by a negative number, the inequality symbol needs to be flipped the other direction in order to keep the statement a true statement. So I mention this because this is going to happen when we're solving some of these inequalities. We'll find this situation where we're dividing by a negative and we need to make sure we take the symbol and flip it the other direction. The other quick thing I just want to review with you is how the equation of vertical lines look as opposed to horizontal lines. Okay, so if we're talking about a vertical line, the equations of vertical lines are always x equals, and then it's a number. X equals 5, x equals -2, x equals 7. Whereas horizontal lines, those equations, so we're talking about lines that look like this, have a y in them with no x and then a number. Okay, so vertical lines are x equals, and horizontal lines are y equals, and that will come up particularly with the word problems that we're going to be looking at here today. Okay, so let's go back and take a look at these steps for solving by graphing here. What you're asked to do first of all is you're asked to graph each inequality, and you're supposed to shade the correct area. I think that's going to be the new part here today. We didn't have any shading whenever these were equations, but we're going to be shading because we're talking about either everything greater or less than our line. Okay, and so if it's greater than, we are going to be shading above the line, as opposed to if it's less than, then we want to shade below the line. Okay, now it is very important though that your equation is solved for y, or your inequality is solved for y first. So let me make that little note here. In order for us to graph, it must be solved for y. Okay. Also, when you're graphing these lines, another thing worth noting is if there is a little equal to bar. Let me give you an example. On this inequality symbol, see how there's an equal to bar underneath it, whereas on this one there is no equal to bar? If there is an equal to bar, then we need to be graphing the line as if it is a solid line, how you would typically think a line would look. If there is not an equal to bar, like here's just a greater than, here's just a less than, when you graph the line should be graphed as a dotted line. You can see this example here, how this is just a dashed or dotted line. Okay. So Your answers to these, instead of being like one point of intersection like the equation, will be these shaded areas, and we're looking for just really where the shaded areas overlap each other, and all the points in that overlapping shaded area that represent the solution to your system of equations. So let's start with example A. Now I should tell you that you can see in this first example, even in the second example, these equations are already solved for y for you. Please be careful. If these were not solved for y, like in example C, see how the y is not by itself, that has to be your very first step, is to solve for y. Now you can think of this as y equals mx plus b. I got this first one started for us. I plotted a point at the y-intercept at -4. I used the slope 2 over 1. I counted up 2 over 1, up 2 over 1. That's how you see these green dots here. And then I chose to graph this line not as a solid line, but because there was not an equal to bar underneath, I graphed the line as dotted. And that's all the farther that I went on this particular problem. So we need to kind of pick it up from there. Okay. As I look at this symbol, because it's a greater than symbol, I'm going to shade above the line. Okay, when we talk about shading above the line, I want you to make this little note to yourself here. Above the line means that you're going to be shading the side of the line that includes the top of the y-axis. And anytime that you're going to be shading below the line, you will be shading the side of the line that contains the bottom of the y-axis. So I like to think of it like this. If you were to lay your pencil down directly on the line, which side of that pencil contains, since this is a greater than symbol, okay, this is, we said greater than, right? Greater than. Which side of the line contains the top part of the y-axis? Well, that would be all of this line here. So you can just take your pencil and maybe just kind of use some strokes all going in the same direction to show that right now that's the side of that line that we are going to shade. Okay, now we have a totally separate line that we're also going to graph this equation here. Okay, you'll notice this is already solved for y, so we can go ahead and start by plotting the y-intercept at 3, so we're going to count up to 3. I'm going to go ahead and put a point there. And then notice that our slope is -0.5. That technically means that the slope is -1 over 2. So that means I'm going to rise up 1 and I'm going to go to the left 2 because my slope is negative. And you can see I'm kind of continuing that pattern a few times here so that I have multiple points. Now before I connect these dots, I need to look closer at my symbol and I need to determine whether I should be graphing this as a solid or a dotted line. Since I have an equal to bar here, I am going to graph this line as being solid. So I'm going to go ahead and run my pencil through those points there, making the line solid. Now I need to again look closely at what symbol I have here to determine whether I should be shading the side of that line that includes the top part of the y-axis or that includes the bottom. I have a less than symbol, so that means I'm going to shade the side of this line right here that includes the bottom part of the y-axis. Okay. Sometimes I like to take my highlighter and just highlight the y-axis. I'm going to shade the side of this line that includes the bottom part of the y-axis. So again, I'm going to shade using a pencil stroke that maybe goes in a separate direction than what my other pencil stroke went. That way I almost see like this plaid design right here. This is where the two shaded areas overlap. So now I would want to take my pencil and you don't have to completely shade it in so there's no white space, but you want to make it very prominent that this right here, this section right here is where both those shaded areas overlap. So any points that fall in this shaded area right here, the x and the y value would make this inequality as well as this inequality true. Okay. All right, let's go ahead and try another one here. And this one nicely is already solved for y for us. So we're going to start with a y-intercept of 5. And I can see that the slope is 1, which means 1 over 1. I'm going to rise up 1 and go to the right 1. Okay, I look closely at my symbol and I see there's an equal to bar. When there is an equal to bar, I'm going to connect these and make them solid. So I'm going to go ahead, and when you make your line, make sure to really try to extend it all the way through the entire grid here. Okay. Now I have to shade a side of that line. So I'm going to go ahead and highlight my y-axis. Look closely at the symbol. It's a greater than symbol. So I want to shade the side of this line that includes the top part of the y-axis. That would be this side right here. I'm going to be shading. Okay, now I'm going to go ahead and graph my other line. The y-intercept is -4. This one also has a slope of 1. So I'm going up 1 over 1, up 1 over 1. Okay, when I graph this, I notice this one has no equal to bar underneath it. So these points get connected as a dashed or dotted line. Now, these two lines have the exact same slope, and we discussed in the previous chapter about how that means that these two lines are parallel to each other. Now let's look at the symbol here. This is a less than symbol. Less than means I should be shading the bottom part of this of the y-axis, so the side of this dashed line that includes the bottom of the y-axis. Well, that would be this side right here. Now my final answer is supposed to be where the first shaded area overlaps with the second shaded area. In this particular instance, and because the lines were parallel like this and we're shading on the opposite sides of the parallel lines, there is actually no intersection at all. So that's when I would write down that the answer is no solution. Now, had we shaded, this side of our first line and this side of our second line, then our answer would have been all this section here in the middle. Okay. All right, let's try one last one of this type, and this one's going to require us to rearrange the equation so that it is solved for y. Now, I realize that we reviewed at the beginning that anytime you divide both sides by a negative, you flip the symbol, and it doesn't look like that's actually going to happen on either of these two examples, but it's going to happen on at least one example in your notes. It usually happens when the number in front of the y is a negative number, and then in the end you end up dividing everything by a negative. That symbol then has to be flipped. Okay, let's go ahead and graph. Y-intercept at 8, right there. And the slope on this is -4 over 1. Now, if I go up 4 and left 1, I'm going off the grid. So I'm going to go down 4 and I'm going to go right 1. Okay, I'm looking closely at the symbol. I see an equal to. By the way, when you look at the symbol, make sure you're always looking at the symbol in the equation that's been solved for y. Don't look at the symbol in the original equation, because sometimes that symbol gets flipped the other direction. You're always looking at the equation that's been solved for y. Okay, I'm on this one here. I see an equal to bar. We said equal to means solid, right? So I'm going to go ahead and make a solid line here. I'm going to highlight my y-axis so that I can tell what side of my line has the top and bottom of the y-axis. This is a greater than symbol, so I should shade the side of the line that includes the top part of the y-axis. That would be this side right here. Okay, now I'm looking back at the equation that I've rearranged, solved for y. Y-intercept, -4. So I'm down here, 1, 2, 3, 4. This one is having a slope of 1 over 1. I look closely at my symbol, no equal to bar, so this is going to be dotted. Go ahead and make that dotted when I connect it, and my symbol is a less than symbol. I should be shading the bottom part of the y-axis. That would be this side of the dotted line. Okay, you should be able to tell where these shadings overlap. Looks like they are overlapping right here in this space right there. Okay, should probably extend that line a little bit more right there. Okay, that represents your answer. We're going to try just a couple of word problems. These word problems are going to have us create inequalities like these, and then we will solve them for y and graph like we did here. Okay, so here this first one's talking about Chelsea. It says she has final exams in 3 subjects, calculus, physics, and history. She has up to 25 hours to study for the exams. She plans to study history for 2 hours, so she knows how much time she wants to spend on history. What could vary is how much time she's going to spend on calculus and physics. Okay, it says here that she needs to spend at least 7 hours studying for calculus, but anything over 14 hours is too much. She hopes to spend between 8 and 12 hours on physics. write and then graph a system of inequalities to represent this situation. So when you do this, you need to start by defining what are your two variables going to be. Well, really, I know there's 3 subjects here, but remember, she kind of has locked in how much she's going to study for history. She knows she wants that to be 2 hours. So our 2 subjects that are kind of variable are how many hours she spends studying calculus and how many hours she spends studying physics. So I'm just going to let X be the hours spent on calculus, and we'll let Y be the hours spent on physics. It is important that you define what your variables represent. Okay. Now let's look back at the beginning of the problem. It says here that she has up to 25 hours to study for these exams. Now remember, 2 of those hours is going to be taken up by physics. So technically she has 23 hours left to spend on both calculus and on physics. So if I were to add together the amount of hours she spends studying both of those subjects, she only has up to 23 hours to spend on that. So I should be using a less than or equal to symbol there. Okay, there's one equation. Now, the other one is going to look a little different here. We're exclusively talking about physics here, or calculus. She wants to spend at least 7 hours studying for calculus, but not over 14. Now remember, calculus is the X variable. So what I'm going to do is I'm going to sandwich an X variable in between what looks like 2 less than symbols, but really this one is acting as a greater than symbol. And I want to put numbers on each end here. Basically, if she wants to study at least 7, that means that she's going to do greater than or equal to 7, but she doesn't want to go over 14, so I want to keep it less than or equal to 14. Okay, so there's another one. And then we want to kind of do the same thing here with the physics. She's going to spend between 8 and 12 hours on physics. Now remember, physics, that's the Y. So we want to set this up Y, and it's really up to you. If you want to put an equal to bar because it's not quite as clear, or not put an equal to bar, that's fine. Okay. Okay, so let's go ahead and start with graphing this line because this one has X's and Y's in them. We always want to make sure we solve for Y. So I'm going to take this equation. We're going to solve for Y. I'm going to bring the X over. Here's the equation solved for Y. I'm going to have you just make the Y-axis be the left side here of our grid because we're going to be kind of plotting this focusing on just quadrant 1 here. Okay. I think that you might find this a little bit easier if we think through plotting the x-intercept and plotting the y-intercept for this instead of plotting the y-intercept and trying to count the slope. I think we have 20 squares this way and we have 20 squares this way. So if we go up to 23, we're kind of off the grid. It makes it a little difficult maybe to count up and over our slope of -1. Remember in the previous chapter, we had equations in standard form, and we said the one time where standard form is actually helpful is when you want to plot the x-intercept and when you want to plot the y-intercept. Now remember, the x-intercept is found if you just substitute a 0 right here for the y. You can see the x-intercept is going to also be at 23. And again, I realize that goes off the grid a little bit here, but we're just going to kind of go over 1, 2, 3. I'm going to go ahead and say right here at 23 is the x-intercept, and then we'll extend this up a little bit, 1, 2, 3. We'll say 23 is also the y-intercept. We can see that here. We can also see that if we plugged a 0 in for the x. Okay, I have those 2 points. I need to connect them, but I need to look back at my symbol. Okay, you do have to solve this equation for y because you need to make sure that this didn't get flipped when you were solving for y. It has the equal to bar, so I'm going to go ahead and connect both these points as a solid line. And then my symbol is a less than symbol. That means I'm going to extend my y-axis because we kind of lost the top part of it a little bit. Here's my y-axis. I'm going to highlight that. I need to shade the side of this line here. This is less than, that includes the bottom part of the y-axis. So I'm going to be shading everything on this side of the line. Okay? Now when I go to graph this, remember we reviewed at the top here how vertical lines look. The equation of vertical lines, we said, are just have an x in them, and when it's horizontal, it just has a y. So for this inequality, because there's just an x, I basically need to graph two vertical lines, one at 7 and one at 14. So let's do that. Okay, I'm going to go over 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4. And here's at 14. Because I have equal to bars, I'm going to make these two vertical lines solid. Solid there. Solid there. Now look at the shading. X should be greater than 7. Vertical lines are the one time that you don't really look at what side of the includes the y-axis. Instead, you think, should I shade to the right or to the left? Greater than means shade to the right. Less than means shade to the left. So basically, I'm going to be shading to the right of the line x is greater than or equal to 7, and then I'm going to be shading to the left of this line right here where x is less than or equal to 14. I'm trying to shade with a different pattern every time, so I'm shading to the left of this. Now, I don't know if you can tell, but where all three of these are overlapping right now is kind of in this region right there. Okay, I got two more lines I need to graph. These are going to be two horizontal lines. They're going to go through the y-axis at 8 and 12, and I'm going to make them solid. So I'm going to count up 1, 2, 3, 4, 5, 6, 7, 8 here. And here's one at 12 here. Okay, let's look at this first one. Y is greater than or equal to 8. Greater than, that's this line right here. I should shade above that line, what includes the top part of the y-axis. Okay, so if I shade that, that would be everything above that line. And now I need to shade everything below the 12. Here's where I think I should start to be able to see where things are overlapping. I think it's this little, almost like a trapezoid-ish shape right in here is where kind of all the overlapping shaded regions all collided. So what this means is if you pick any point in this shaded region, the x-coordinate and the y-coordinate would tell you how many hours she could spend studying calculus and physics that would satisfy all of these requirements here that she's kind of set forth in this particular problem. Okay, now those word problems are a little tricky. You do have to set up your inequalities and define your variables first, then you come over to the graph. That's where we're going to stop here today. You can see that your assignment is for you to complete worksheet 3.2a.